This next video is affecting the A and the B value, but we're going to add one more thing that the A and the B can do, and that is reflections. So if the A value is less than 0, so if the A value is negative, what it's going to do is reflect your graph over one of the axes, right? So it's going to reflect some values over some axis. Let's see if we can figure out what. Well, we know that this affects y, right? The A value, anything not in the bracket with x, affects y. So if I have a point 2, -8, I'm going to multiply the y value by -1, and I would then have a point 2,8 on my reflected graph. So again, if I had a point 2, -8, oh, I didn't really do it. I should have chosen one where that's a point on this graph. That was silly of me. But anyway, so if I had a point 2, oh, I did kind of. All right, so if I had a point here, 2,8, and it gets reflected down to 2, -8, what did it get reflected over? So when you reflect the y values, you go over which axis? The x-axis. So when the A value is negative, it reflects the y values over the x-axis. How does this transformation look? Well, again, it's an A transformation, so it affects the entire equation. So you think about negative f of x means that if my equation is defined as x cubed minus 4x squared, the negative would go out front of everything and it would make all the signs change. So you get negative x cubed plus 4x squared. So a transformation on y affects the entire equation. Now let's look at the b. So b is a transformation on x. So we're going to reflect the x values over which axis? Well, this one, there is no opposite, like dividing by -1 is the same as multiplying by -1, so don't worry about opposite operation. So let's just say I'm going to multiply the x values by -1. So if I have a point 2, -8 on my original graph, so 2, -8 down here, and I want to know where that point is going to be on my reflected graph, I'm going to multiply the x value by -1, and I get -2, -8. So I reflected the x values over the what axis? Y-axis. So when you have a negative b value, it reflects your x values over your y-axis. What does that look from an equation standpoint? Well, the x would be, or the negative sign would be in the bracket with the x. If it was an equation, you would have to put the negative with the x. So you get negative x all cubed minus 4 times negative x all squared, which would simplify to negative x cubed minus 4x squared. All right, let's do a couple, and then you can go and practice just this skill. This one, you have to decide, is it a reflection of y values or x values? Since it is an a value, this is going to multiply my y values by -1. So again, you can pull out your key points. There's one here, here, I'd say there, maybe, there, and there. So I've got 1, 2, 3, 4, 5. That one I don't really need. I just want to show you what happens with it. So let's say we pull out those points. We've got a point at -4, 0. We've got a point at -2, 3. We've got a point at, gosh, that's like -0.75, 0, maybe. A point at 0, -2, a point at 1, 0, and a point at 2, 0. Okay, so we're going to take all the y values and multiply them by -1. The first thing I want you to notice is that any point that has a y value of 0 won't change. It's still 2, 0, it's still -0.75, 0, and it's still -4, 0. It won't change. So these are my invariant points, because to reflect them as the y values over the x-axis, they're on the x-axis, so they're not going to change. Actually, none of these points are going to change. So I'm going to highlight that all in blue. It's all the other points that are going to change. So this one here would go to -2, -3. So you take this y value, you reflect it over the x-axis, and it would go down here to -3. So now I can go like that. Oh, that was bad. Straighter than that. You guys have rulers, right? And then I'm going to go back up here. Oops, that's bad. That's better. Okay, so this point here at 0, -2 would go to 0, +2. It's getting reflected over the x-axis and coming up here, all the way up. And then I'm going to come back down to here. So, oh, sorry, that was another invariant point, 1, 0. So this graph is a reflection of the y values over the x-axis. Maybe you need the points, maybe you don't, up to you. This one is a negative in the bracket with the x, so this is going to be the x values are going to get multiplied by -1. So this is going to reflect my x values over the y-axis. So again, you could take all these points and take them over, or write down your points and transform them. So all these points are the same. So we have negative 4, 0. I'm taking all the x values and multiplying them by negative 1. So now it's going to be positive 4, 0. So this point here goes to positive 4, 0. We'll do them one at a time. We have the point negative 2, 3 would go to 2, 3. So this point here at negative 2, 3 would go over here to 2, 3. And then I like to connect them as I go, otherwise I lose what the shape was supposed to be. One of these times, I'm getting worse. There we go. I have a point negative 0.750, which would go to positive 0.750. So this point here is going to go over to somewhere in here-ish. I mean, I can just use this point here. So that next point, negative or 0, negative 2 would stay 0, negative 2. So now any y-intercept is an invariant point, so that one's not going to change. So now I have to get from here to here. Okay, and then we've got 1, 0 would go to negative 1, 0. So this point here at 1, 0 would go to negative 1, 0. And then that point at 2, 0 would go to negative 2, 0. So it would be over here. And then I connect my dots. There you go. So that graph is a reflection of the x values over the y-axis. Okay, what about this one? So again, this is that assumption that you know your base graphs. So this one you have to identify that the base graph they're looking for is the square root of x. So let's start by graphing that one. Maybe you need a table of values, maybe you could just do it. When x is 0, y is 0. When x is 1, y is 1. Then I'm going to choose perfect squares. So when x is 4, y is 2. When x is 9, y is 3. Okay, so there is now my base graph. And I really like transforming base graphs, but the textbook likes you to transform base graphs that aren't given to you. They're equations you're supposed to know. So let's do this. Okay, so let's take our key points. We had a key point of 0, 0. We had a key point at 1, 1. We had a key point at 4, 2. And we have a key point at 9, 3. Now, when we do the transformation of negative square root of negative x, I'm going to take the x values and multiply them by negative 1, and I'm going to take the y values and multiply them by negative 1. Now, since they're acting on different variables, I'm allowed to do them at the same time. So I'm going to use a different color. Hello. There we go. Okay. So no matter what, if I multiply these by negative, they're just going to stay 0, 0. So this point won't change. Now this point, I'm going to take the x value, multiply by negative 1, take the y value, multiply by negative 1. I get a point here at negative 1, negative 1. Same thing here. I get negative 4, negative 2, negative 4, negative 2. And then lastly here, negative 9, negative 3. Negative 9, negative 3. And that is a reflection of the x values over the y-axis and the y values over the x-axis. So I did them both at once. You could have done an intermediate step. You know, you could have flipped it here first, right? You could have reflected it over the x-axis and then put it over, or maybe you could have done it over the y-axis here. So you could have done this, guys. So you could have said, hey, I'm going to reflect it over the y-axis first and then reflect it over the x-axis. But I find it easier, especially if you're doing it by a point basis, just to multiply the x values by negative 1, the y values by negative 1, and get a solution. All right, go and practice reflections.